Hey everyone, welcome to another episode from Pro Engineering. In this episode, we are going to install this blower assembly onto the Axial SCX10 Ford F100. So I guess starting at the base is the main mount. This will mount into the front shock towers, and this front mount will go into this extension, which will go from the battery tray directly in front of the servo and go just like that so that you can pull it out with some body pins. Next, you've got the main supercharger. Now, it's not modeled after a particular supercharger. I just looked at what superchargers looked like and whipped one up. This one does have dual carburetors on it, and there are some details that we'll talk about shortly, but this is simply the main unit. And I have been sanding it down just to clean up some of the layers on this thing. This was printed on a polyjet, which is what you'll get at Shapeways if you use the ultra detail plastic. But if you go through MyMiniFactory, I would recommend using a resin printer to get as close to the polyjet as possible. This is the bottom and the top of the scoop clamshell, and in between go the butterflies. So those will drop right in there, just like that. And when you accelerate, they'll open up. To do that, we have a couple of linkages here. We have 6 of these linkage retainers, and we have these spacers that we'll talk about later. But basically, the spacers will go directly into the blower where the carburetor is, because we're going to have some pins that stick out of there that go to these. These little guys will connect and act like parts of the throttle linkages so that when you accelerate, the quote-unquote butterflies in the carburetor open, as well as the butterflies in the scoop. The supercharger has a pulley. This pulley will go inside of here, and you will have a 130 sized motor if you have a mini 4-wheel drive. By Tamiya, that is the size motor that it will use. And the motor is retained by this motor retainer. The first thing I want to do is detail these up a little bit. So like I said, I have sanded these down to get rid of some of the layering effect. And I do want to go ahead and paint this in a chrome paint. This will be painted in cast aluminum, which will work for the carburetors as well. I did also want to note that there's one thing that's not here, and that is the fuel lines, because I want to have a separate part, which I just forgot to print. So that's not shown there, but otherwise, let's get some paint on these guys. Step 1 in the engine installation is going to be installing this bracket. Now this is going to hold the supercharger, and this piece here is going to hold the front of that bracket, and then there's a little retainer for that. So this is how this works. You'll place this little standoff right here on the factory bracket. Now this is the Pro Servo winch bracket, but this will work the exact same way with the standard one as well. So put that there. I apologize, I just pulled this off the printer and did not have a chance to clean this. At the bottom, you'll tap this with a M3 tap, and I drilled it out previously just to clean it out with a 2.5 millimeter drill bit. That goes there. And then rotating this guy, you can see where the 2 screws are right there. And then this little bracket here, I've put the 2 screws in it already, will go onto it and hold it in place. You see there's a slightly longer side. The longer side will go toward that wider flat area right there. Now that the front mount is in, we can drop this straight down. So to hold this down, a body pin will go straight through this hole once you've placed it there. And at the rear, you want to tap both of these with an M3 tap. Drop those in place and just slide a screw straight in here, and it will only tap into this and not into the 2 other holes because those are greater than 3 millimeters. Now that we have the front mount installed, we can install the main plate and then the supercharger. And the reason why we want to do this is to make sure that the body has the proper cutout. Now I'm fortunate, I have a clear body as you can see, and I'm going to use this to make my cutout. And for those of you that don't, I will make available a 2D drawing to show you roughly where the cutout should be. Now that the top and the bottom half of the scoop, as well as the little vent flaps, are painted, let's go ahead and reassemble them. Okay, so this is the bottom. The flaps will go right in like that, and then the top will just drop straight in place here. To assemble them, I'm using a 6 millimeter long M3 screw, and I tapped every single one of these holes with an M3 bottom tap. I also tapped these 2 holes here because we'll need that to attach to the blower. You will also want to make sure that these are cleared out with a 3 millimeter drill bit. I'll drop that straight on top, flip this over, and install all 4 of these. And this is fully assembled. So there's no friction here at all with the butterflies. And we have those 4 screws at the bottom. We'll grab our supercharger, which has been detailed up a bit. I plan on doing a little bit more when it's assembled, but we'll get to that later. Set this on top. just like so. And again, from the bottom, we'll install those 6mm long screws. I also like to make note of something. The screw head that you see in there must be sub-flush to the area around it. There's so little space to work with in here. If the screw head sticks up more than a few, I would say maybe more than 1/4 millimeter, it'll come into contact with the side of this barrel and prevent it from rotating. This screw head is close, but what this was designed to use were the much shorter standard Tamiya screw head. These are just under 2 millimeters tall. So this is what you're going to want to use. There they are, screwed right in at the bottom. Now that the scoop is installed on top of the blower, or I should say on top of the carburetors, which are on top of the blower, we're going to install these rods, these 2 little pivots, and these 2 retainers. These are 3mm rods. They can be steel, they can be aluminum, stainless, whatever you find. Make sure you clean these holes out. These are designed to be 3.1 millimeters thick, but depending on the printer and the material that you're using, they could be undersized. So if you run a 3mm drill bit through these, that should clear them out for an undersized 3mm rod just fine. This one measures at about 2.9 to 2.85, so it's just under 3 millimeters, and you'll want to do the same to these guys. The longer rod is 34 millimeters. The shorter rod is 28 millimeters. So we'll start with the longer one. And we'll just slide that straight in here, theoretically. There it goes. Okay, and right as it gets to the end here, you want to put a little dab of glue on that and then pull it through until it's sub-flush, and then that should put enough adhesive on it to make it secure. And here is the longer of the 2. And we'll do the same to the shorter of the 2. And both of the linkages are all glued in place. And it's a little bit hard to see here, but in the middle, I roughed this all up with the Dremel tool because I just like to give it a little bit better of a spot for the glue to bond for this next step. Here's where everybody's gonna hate me. You've got to take these little sleeves, and these are what you're gonna glue onto the shaft to prevent them from sliding out. And basically drop them in there, never to access them again. And then we're gonna take this, theoretically, and oh my God, how did that actually line up? I cannot believe that lined up. And just push it all the way through. A little bit more. Okay, once you've got the linkages in place on the bottom, those little holes there, those are there to allow glue to penetrate. So put a little dab of model glue in both of those and let it dry. Do not do that much because glue will wick. Wicking is when a liquid gets between 2 surfaces that are close together or even touching and spreads a great deal of distance because very little volume is necessary to wick. This means it can wick and come into contact with one of the sides of the supercharger and lock it in place. Remember that there are holes on both sides of these, so you can glue both regions there. And that should prevent these from sliding out. And you want to make sure that there's a good amount of freedom here. They shouldn't, they may not spin if you just whack them and kind of rotate freely, but there's very, very little friction here, so they're very easy to rotate. So next we'll install the motor. For the supercharger drive pulley, we have the pulley, and then we have this little brass tube. Now the brass tube you have to find at a hobby shop. Oftentimes they have a number of random sized brass tubing. The inner diameter is 5 millimeters and the outer diameter, this is critical here, is about 5.9 to 6 millimeters. The length that you have to cut it to is just about 22.5. This is 22.4. It's pretty close. And what you're going to do with this is slide this over the shaft here. Now watch on the inside, see those little slots in the retaining ribs. This is going to go all the way down. Rotate it a little bit here. So go all the way down to the base. And what this does is after we glue this in place, the glue will bond between the brass and this rib here along all 4 sides, preventing any kind of cracking or bending of this plastic. If you are going through shapeways and getting the ultra detailed plastic, in very rare instances, I've seen it where these can potentially bend over time. And I don't want that to happen simply because of the moment that you're looking at here. I mean, this is sticking out about 15 millimeters, and I just wasn't too comfortable with that. We'll cover this shaft in some high quality model glue. And then down in here, I'm going to use a CA glue. Next, we'll flip the engine over and we'll take our motor. Now this is a standard 130 motor. This is Mabuchi 130. In this case, I've located this kind of cool one that has a shaft coming out the rear as well as a longer one in the front. And I find this a little more advantageous in my application because the pulley that we worked on earlier does have the depth to have the longer shaft, kind of go all the way. But this thing does not have a hole deep enough. It only has one to accept this one here at the rear. So if you want it to go in the maximum, or at least I wouldn't say the maximum, but at least as long as this one here, you will have to drill this out with a 2mm bit a bit deeper. Do this after you have installed the brass sleeve and glued it in place. Otherwise, you easily risk breaking this. This shouldn't be necessary with the brass sleeve, because this is also here to help to prevent any kind of moment here on the pulley, prevent it from shearing off at the depth of the original motor shaft. My, that was long-winded. Let's flip this over, drop this sucker in here, just like that. Don't worry where it goes, because this little retainer will hold it in place. This motor, when I was test fitting it earlier, it's a little bit sloppy in here. I don't know if it's undersized. I designed this to the specification available from Mabuchi. It's possible that this just isn't an official motor. In this case here, I'm going to apply just a couple little dabs of hot glue just to prevent it from rattling around. And there is the other one. There it is, and the motor is now in place. In my application, this is a pretty nice fit, so I'm not going to use any kind of adhesive to hold it down. You are welcome to do so, but we want it to have it go as far as it can, just like that, before coming into contact with the supercharger body. And there we have it. That's pretty cool. Technically, we should have had the wires soldered onto this already. I'm actually out of them right now, but I've got some on order, so in the next scene, I'm sure I'll have the wiring. If you thought this linkage installation was ridiculous, well, moving on. These little 3D printed linkages are going to come in here and attach all these little bars together. So that is how that is going to work. And there's another one. I'll try and go here to here if I can show this. Just like that. And you might be thinking to yourself, oh, that is not so bad. That looks pretty easy. Well, that is because this is only half of it. The hard part is there are little retainers that glue on the inside. That is going to be horrible. You've seen where these two linkages go. We can keep them there. These are the retainers that you glue on the back side, and these should have a slight press fit. So once they're installed, they pretty much should stay there until you dab a little tiny dab of glue to the back, and then you're all set. Only 4 are required, but I printed 6 so that you can lose 2. Okay, here is one of them, and we'll start with the least worst one to install. You can see on the back side, there's, I really can't, see those 2 little studs that are sticking up. They're sticking up maybe 1/4 millimeter, but it's enough to where it could cause issues. So flip it over to the flat side, and then who designed this? We should be able to just, oh my God, how did that work? Did that really, it worked. Oh my God, I cannot believe that worked. Okay, that is probably, oh, it's totally on. Wow. Okay, let's leave it there. It shouldn't come off. And then we will address the other 3. And once we've completed all that, we can put a little dab of a high quality model glue. And I must reiterate, you cannot use a super glue, because that will just, that's game over. It'll bind everything up. They're gonna get progressively harder to put in, I suspect. Okay, that one. Okay, that's in. We'll start with the next least worst. Oh God, how are we gonna do that? Maybe we can get it from here, from right there. Okay, as it turns out, to put this one in, you spin everything forward about as far as it'll go, and then it's not too bad to get it on. I have already applied some adhesive. Oops, that rotated the wrong way, didn't it? Hang on, let's fix this. There we go. Overextended. Okay, there we have it. Next, we'll install our servo. I'll have some servo dimensions and properties up on the screen right now, but this is just some micro servo that I came across in my collection, and this is what we're going to use. These are the mounts for the servo, and again, this is only going to be if you want to have the flap actually opening and closing. You can always lock it in a certain position or do whatever you want. These, if you're going to use this, are going to be tapped with an M2 tap through these holes, and then we'll install the servo like that. All right, I skipped a few steps only because there's a couple things here that I discovered were utterly impossible. This bar here that I said we'd install once we put the servo horn on is utterly impossible to tie into this and this, having to go through this slot. So the production model will have this slot completely opened up. Otherwise, you're going to lose your mind like I just about did. Once I installed all of that, it was all good to go. And just a heads up, and you see what I did here. The motor is being controlled by this old Futaba because it is a manual adjustment. I have the neutral point set slightly forward so that when you turn it on, the blower is spinning. And then we have a Y splitter right here, which also goes to the servo so that when you accelerate, you do want to set your endpoints so that this does not overextend. You can see mine doesn't actually clash with anything. Does anybody see though that I've created a major problem here? Anybody have any idea what I have done? Now this all looks fine at idle and accelerating. The problem here is reverse. So you can see I dramatically cut back the servo endpoint in reverse because this will bind up here if it goes back too far. And that'll be okay with my speed control. It still goes into reverse. The main issue is that the butterflies open the wrong way. Well, I mean, not really. That's not a huge thing. More like the blower motor stops working. This is just how I'm going to run this. If anybody is smarter than I am, I'm sure many of you out there are, and have a better application here, probably using some kind of Arduino. I've never dealt with any of that stuff, and this is going to be acceptable for me, but I would love to hear better ideas. You know, I wish I could have had it a little bit thinner on this side, or I should say the gap narrower, but the problem is then this linkage here has to fit within the gap, and then the whole scoop does have to fit through the hood. I know usually the Supercharger is probably a little bit wider than the hood is, but I kind of wanted to over-exaggerate the scoop because I just think it looks cool. Anyway, if you are interested in this, I will make a PDF available so that you can at least download it and plop it on the hood and you know, adjust it to your liking. But this is pretty much the clearance that we're looking for here. Probably should paint the body. I wanted to point out the fuel line is this bit right here that we've installed. It slots into a small hole into the side of the carburetor, and you'll just push it in there, put a dab of model glue and a dab of glue here at the base, and there's one for the front and one for the rear carburetor. Here you can see that I've gone ahead and wired the AC solenoid. And I've done that with a 0.5 millimeter thick wire. I just stuffed it in that little hole in the back of both solenoids and just put a little dab of CA glue top and bottom. I also wired up the cold start choke. You can see right there with a couple of, these are actually very, very small gauge wires, and the same as before, a dab of CA glue in both of these little holes, and then I just routed the wire as you see it there. This is a 1/4 millimeter thick wire. On my vehicle, the linkage here from the center to the center of the bend is 32 millimeters long. And that's going to be dependent on the length of the servo arm that you have. And remember that you don't want to have the servo arm extend too much, and you certainly do not want it to have it extend in reverse too far because you risk damaging or breaking this arm. This vehicle has one little addition. I put this little switch because this controls the shift light indicator on the tachometer with the interior, which we'll cover in a subsequent video.